I know I talked about this the other day. I'm going to quickly run through this again. This is a continuation of 1.3, right? 1.3. So this would be what you would use in order to help you guys get through section 1.3 or assignment 1.32. And limits of polynomials and rational functions. If P is a polynomial function and C is a real number, then the limit of the polynomial, called P of x, you can find by just plugging in that value of C into the function rule. Now, polynomials are continuous. They go on and on and on. There's not breaks or gaps or anything else or asymptotes, so all you need to do, that's one of the reasons that you can just go ahead and plug that x value or that C value right in for x. If R is a rational function given by R standing for a rational function. A rational function just meaning you've got a polynomial over a polynomial. Well, you just take one of the polynomials, P of x, you divide it by the other polynomial, Q of x, making it a rational function. So to figure out the value of the limit, all you need to do is replace that C value, whatever it's approaching, into both x's, the x on the top and the x on the bottom. And then as we talked about the other day, we're going to sometimes you run into problems when you do that, so we need to start exploring some other options. So this example right here, the limit as x approaches 1 of x squared plus 5x plus 4 over x plus 1. If you take this x value of 1 and you plug it into the bottom, you're going to get 1 plus 1. Is it okay to have 2 on the bottom of a fraction? Yeah. Of course it is. So that's not an issue, but we're going to start running into issues which is where you're going to need to use the dividing out technique, which we talked about the other day. So, because the denominator is not 0 when x is equal to 1, you can just substitute x with 1. So you can just take this 1, you plug it in, you get an answer of 10 over 2, which gives you a value of 5. So the limit as x approaches 1 of that rational function is 5. We talked about these trig functions the other day too. Whenever you have a trig functions are continuous. So all you need to do is plug in these values into the function, get an answer out of it. Those are probably the easiest of all of these things to use. All right. Examples. We talked about those examples the other day. And I believe this is where we left off. If the denominator is 0, then try the dividing out technique. Actually, we talked about this briefly, didn't we?
Yeah.
All right, so in this case, we have a -4. And when you plug a -4 in for x, you're going to end up with 0 on the bottom. You happen to also get 0 on the top. If you get 0 on the top and a 0 on the bottom, that means that we have something called indeterminate form, which means that the limit probably exists, you just need to explore some other options. Remember I talked about a moment ago, if you don't get 0 on the top, but you do get a 0 on the bottom, the limit does not exist, and you can write DNE, does not exist, and get on with your life. But if you get 0 over 0, you're going to need to explore some other options, which is what's going to happen today, a lot. So, try factoring. We talked about this the other day, x squared plus 2x minus 8. When you factor it, you're looking for two numbers that multiply to give you -8, and when you add them together, they get you +2. Those two values are x plus 4 and x minus 2, divided by, and then of course we saw that as x plus 4 on the bottom. Hey guys, huge hint here. Put that away, please. Huge hint here. When you have x plus 4 on the bottom, and you're trying to factor the top, there's a really, really good chance that one of the factors on the top is going to be x plus 4. So keep that in mind if you're struggling to come up with the factors. It's probably going to match something on the bottom. That's the little hint there. All right. So the x plus 4's cancel out, leaving you with x minus 2. All you need to do then, of course, is to plug that. I'm going to scroll down here a little bit. All you need to do is plug in that value of -4 into your function, plug it in to your -2, leaving you with -6. So the limit as x approaches -4 of that rational function is equal to -6. All right, the rationalizing technique. Hopefully this kind of sounds familiar to you from last year. You have a square root. Whenever you have a square root, that always screws things up. So if you have a square root, you're going to need to try some other options. One of them being the rationalizing technique. So if x is approaching 0, you put a 0 in here on the bottom, you get 0. You put 0 also in for this x right here. You have 0 plus 4, which is 4. You take the square root of 4, you get 2. Then, of course, you have 2 minus 2, which is 0. So, again, you have 0 over 0. What is this called again? Indeterminate form, which, of course, then means you need to explore other options. Okay, so rationalizing. This is what you need to do. You see the square root of x plus 4 minus 2. This is the function. Notice I don't even have the limit written down right now. We're just going to work with changing the function around a little bit here. So we have the square root of x plus 4 minus 2 over x. Well, that is equal to the square root of x plus 4 minus 2 over x times, I'm going to take this numerator and I'm going to multiply it by its conjugate. Do you remember that word conjugate from last year? Yeah. The conjugate of it is exactly the same thing, except you change the minus sign to a plus sign. And it just so happens when you do that, everything cancels out nicely. Your square roots are going to go bye-bye, and everything will be good and happy. So when you do that, you're going to FOIL. You're going to FOIL the square root of x plus 4 times the square root of x plus 4. Well, since these things are exactly the same, the square roots, when you multiply them, are going to disappear. So the square root of x plus 4 times the square root of x plus 4 is x plus 4. And I skipped a huge step here. But I was hoping that last year, you would have remembered from last year, that when you have you're multiplying by exactly the same thing, the only difference is the sign. Those middle terms just automatically cancel each other out, leaving you then with just negative 2 times 2, which is minus 4. And then on the bottom, you have x, and you need to multiply it by the square root of x plus 4 plus 2. In other words, you have to multiply this denominator of x by exactly what you multiply the numerator by. By the way, when I multiply the numerator and the denominator by the exact same thing, what am I really multiplying by? 1. Can you multiply anything by 1? Yeah, if you have 5 and you multiply it by 1, it's not going to change the value of 5, is it? No. So what I'm doing here really is just multiplying by 1, so it doesn't change the value of what I've started with. I'm just changing the way it looks. All right, so when I do that, I end up with x plus 4 minus 4 over x times the square root of x plus 4 plus 2. The plus 4 and the minus 4, they cancel out. Part of the reason we did this. We have an x, all we have left here is an x, and it cancels out with the x on the bottom. So these, that's what happened here, the x's are canceled out, leaving you then with it leaves you with 1 on the top. Remember, if everything cancels out on the bottom, or excuse me, on the top, you still have a 1 on the top. You always have a 1 left over. So there's a 1 on top, and on the bottom you have the square root of x plus 4 plus 2. So really what you're doing is calculating, see I've written the original function down again. So this and this mean exactly the same thing. I just did all this math to come up with a different way to write it. This function right here is the same as what I started with. So now all I do is replace the x's with a 0, and I end up with 1 over the square root of 0 plus 4 plus 2, which is the same thing as 1 over 2 plus 2, which is 1/4. Yes? Okay. And of course, watching me do one, seeing me do one, having it right in front of your face, oh yeah, it makes perfect sense, but of course you guys are going to need to try these by yourselves. So that'll be your test if you know how to do it. All right, last page, and this page is not, I don't think it's horrible. 2 special trig limits. Probably should have these committed to memory. Probably will make your life easier. The limit as x approaches 0, notice it says as x approaches 0, of the sine of x over x is equal to 1. That's a definition, just accept it, it's true. The sine of x over x, as you are approaching 0, is always going to be a value of 1. Put a big box, a big star, or something around this because this is going to be really handy. Another one, the limit as x approaches 0 of 1 minus the cosine of x over x is equal to 0. Examples, and this brings you back to last year a little bit. Hopefully you have some recollection of the sine and cosine and tangent. Remember all that stuff in pre-calc? You have to kind of have some recollection of that. So, if you are finding the limit as x approaches 0 of the tangent of x over x, what I did was I rewrote the tangent of x as the sine of x over the cosine of x. Do you remember that from last year? The sine of x over the cosine of x. Why did I separate them like that? Go ahead, Joey. Well, I'm going to multiply them, but why did I leave, what is this, right? What do I got going on here? 1. Right here, the sine of x over x is 1. So I tried to make this look like one of these two properties, theorems, these accepted ideas. So the sine of x, this x, see the x right here? This x comes from the x's on the bottom. And all I'm doing is multiplying it by 1 over the cosine of x. So this sine of x over x times 1 over the cosine of x, if I were to multiply that through, I would end up with the tangent of x over x. I just wrote it differently. You're going to have to explore. It might not work the same time, or the first time you do it. Just remember these things last year? Identity functions, you had to do a bunch of manipulating and moving things around and make them look a certain way. You're going to have to do some of that this year too. So the limit as x approaches 0, the sine of x over x times the limit of x as x approaches 0 of 1 over the cosine of x. I have written them as two separate limits. That's a property we talked about last week. And you have to multiply your answer. Well, the sine of x over x is 1. The limit as x approaches 0 is 1. And then 1 over the cosine, the limit as x approaches 1 over the cosine of x happens to also be 1. 1 times 1 is 1. The value of that limit is 1.
How did
what?
we're supposed to know that is, or you never calculate?
Which one?
1 over cosine.
Oh, you know what? I shouldn't have just assumed. She's asking about this part right here. Are you just supposed to know that that is 1? Are you just supposed to know that? No, you're not just supposed to know that. When you put a 0 in here, what is the cosine of 0? Good, you remember that. I'm impressed that you guys remember that. That's a lot of information. In fact, I have some cheat sheets for you, and I'm going to hand those to you guys today. So the cosine of 0 is 1. So you really are figuring out what is the limit as x approaches 0 of 1 over the cosine of 0. When you put a 0 in here, you're approaching 1. So you really have 1 over 1, which is where that 1 comes from right here.
But when
Okay.
you plug it into your calculator, it doesn't come out the same.
If you plug in just this, if you type into your calculator the cosine of 0,
Oh,
you should get 1. Yeah.
I did 1 divided by cosine.
You did 1 divided by the cosine of 0? You'd still do 1. I think just
I don't know what that is.
probably just typed it in wrong or something. Okay. All right, good. I'm glad you asked because that means you're paying attention. Okay, good. Number 2, the limit as x approaches 0 of the sine of x times 1 minus the cosine of x over 2x squared. Remember, the goal is to try to make it look like one of those two first initial properties. So what I did here was I rewrote this, and the bottom I wrote as 2 times x times x. Do you see this on the bottom? 2 times x times x. And the reason I did that was because I knew if I could just put the sine of x over x, as I did right here, we know what that equals. What does that equal?
1.
It equals 1. We just talked about that. We also have 1 minus the cosine of x if I could get that to be over x, we know that that is equal to 0. This part is equal to 0. This is 0, this is 1. And then all we have to do is just multiply it by a half. So, I know some of you are thinking, do we need to write out every single step? No, you don't have to do that. Some mathematicians, some teachers, maybe in college, if you have to take anything like this in college, your teachers might expect that you do. But I do not expect that you write out every single step. If you want to go right from here, right to here, I am fine with that. So you have your half. There it is. This sine of x over x is equal to 1. And then 1 minus the cosine of x over x is equal to 0. So a half times 1 times 0, what is that?
How'd you get 1 again?
How did I get this 1 right here? Sine of x over x. Look at the top of your paper. By definition, the limit as x approaches 0, the sine of x over x is 1. Like I said, these two things eventually need to be committed to memory. They'll make your life easier.